So great, thank you for attending our presentation. This is the pycsw project status for 2023. Angelos and myself will be giving this presentation. We also have Ricardo here, who's another pycsw developer, and happy to answer all your questions after the talk or beyond. So we're going to start with an introduction to the project for those of you who may not be familiar with it. We'll walk through features and how it's put together and how you install the tool, as well as some of the things that we've been up to recently in the project. We'll also cover some featured projects and deployments that have been going on recently. Then we'll give a bit of a sneak peek into what we're up to in terms of new features and roadmap, and close it out with some words on community. So pycsw is an OGC API records and OGC CSW server implementation that's written in Python. It originally was put forth as a CSW implementation. So CSW is the OGC Catalogue Service for the web specification. Recently, with the proliferation of the OGC API efforts, OGC API record support has been added to the project. It's open source, runs on all platforms, MIT license, and we've been an OSGeo project for 8 years or so. So we fully implement the CSW standard. We're a reference implementation, and we also implement other APIs, not only CSW itself. Like I said, we implemented records. We also support OpenSearch and Open Archives Initiative protocol for metadata harvesting, something called SRU, search retrieval by URL. We also recently added support for Stack and Stack API for that matter. The core workflow for pycsw is for the publishing and discovery of geospatial metadata. So the metadata can be about anything, EO data, vector data, service metadata, and so on. And the idea is that pycsw allows you to put that metadata into a metadata repository and do transformations on it and allow for discovery at different granularities. We've been around for quite some time, and we support both CSW specifications, both 2.02 and 3.0. Project started in around 2010. We started working toward passing all of the OGC compliance tests, and we finally released version 1 in July of 2011. And we really made a considerable effort to get the project included into major distributions, which I think has really helped in terms of adoption and uptake. So we included it in OSGeo Live, as well as Ubuntu packaging and Ubuntu GIS packaging, and so on. Again, we entered incubation in 2013, and we graduated in 2015. We've had a number of high-profile deployments over the years, including in February of 2014, the initial deployment of pycsw to power data.gov. That was the US government's open data initiative. We turned 10 in December of 2020, and in the same month we released 2.6. So we have a semi-regular release schedule. We'll talk a little bit about our current efforts, but we're currently working with the specifications in terms of implementing the specifications for the new OGC API records standard. We also continually try to use libraries and packages that are upstream. So there's a package called pygeofilter. It was presented last year in Florence. And that is a really, for those of you who are into Python and filtering data, it's a fantastic package made by Fabian Schindler from EOEPCA, and we use that to basically implement the common query language OGC specifications. We added, in May of last year, we added XSL transformation as well as JSON storage. Our storage in pycsw has typically been XML, but we're moving on to supporting more storage capabilities. Again, the goals is lightweight, headless, easy to install, small footprint, and very extensible, and always passes the compliance test from OGC. Move it on to Angelos.
Thank you. Thank you, Tom. Now we'll talk about the features of pycsw. So as Tom already said, we are certified, not only passing the test, but we are certified by OGC for both CSW2 and CSW3. We follow the draft records specification. We are also part of the OGC standard working group, so we are implementing as we are writing the specification, one day at a time. And we have support for harvesting for the old OGC specs. We implemented ISO metadata profile. Of course, FGDC, OpenSearch, all these things are already implemented. We have transactional support since the beginning of the project practically. And of course, we also support federated search and distributed searching. pycsw is very simple to configure. We just have a configuration file, so it's also easy to configure in cloud native applications or architectures today. We support a various number of profiles as well as repositories and backends. It is seamless to integrate with Python environments because you can include pycsw also as a library. So for example, you can implement your own harvester and send data directly from your module to pycsw. It is integrated with various projects like CCAN. We provide a command line utility to administer the metadata, and we also support things like full text search and real-time XML schema validation. This is a list of the standards we currently support. The first one is draft, and the rest are supported throughout those years. That's not, well, we do support CSW, but then we had to implement also filter and common and various other standards along the way. The most recent addition is the Stack API 1.0, which we implemented a few days after it was officially tagged. So yeah, we are testing that also as well. More standards here. These are some ISO profiles and metadata standards here, and we are adapting the schema as new formats are coming our way. So yeah, for example, we don't only implement the Stack API, but of course we implement the collection, catalog item, and all this stuff that come along with Stack. All right, back to Tom.
Thanks, Angelos. The basic architecture, as Angelos mentioned, is we have a core in pycsw, which is driven by a configuration. The configuration is pointed to a repository underneath. The repository by default is a relational database. However, we are extensible and able to entertain other backends given our plugin mechanism. We support a number of different formats, metadata formats that is, whether they're XML based or let's say JSON based, but formal or de facto standards are supported, both import and export. The basic architecture there, again, we use a number of different Python packages to help us achieve the goal of the project, and at the end of the day, the user is provided with a catalog interface to be able to query and discover and search for the existence of data. Over to Angelos.
Thanks. All right, let's discuss about how to deploy pycsw. So of course, as a Python package, it's included in Python package index. So it's very easy to install it by doing a pip install pycsw. Over the years, we have been doing series packaging, so we managed to include pycsw in Debian, and that also then it was available to Ubuntu as well. It has also been packaged for RPM-based distributions. It's available also for Windows, and of course the source code is available on GitHub. We always say that it takes us 4 minutes to install. Sometimes it might take 4.5, but we hope not 5. So it's really easy to create a virtual environment and just install pycsw and just make some edits in the file. We have a default configuration here. You see this file, and we just need to adjust a couple of URLs there, and then it will just work. It's really easy to make it work. It is, as Tom mentioned already, pycsw has been available in OSGeo Live since version 5.5. It's more than 10 years ago. We have there an overview and quick start so people can test it. We have recently deployed pycsw through Docker and also Kubernetes. So there's a project that Tom will talk about later that is used in production in a big Kubernetes environment. So we have provided Helm charts for this, and of course Docker files. So you have all the options. You can directly use the Helm chart or get the Docker file and do your own customization as needed. Back to Tom.
Thanks, Angelos. Latest developments. So we've given you an overview of the project, where we came from, what its goals are, and some of the history. What have we been up to lately? So in September of 2022, as part of the OGC metadata code sprint, we implemented OGC API transactions, which is really OGC API features part 4. So that allows for insert, update, replace, and delete into the repository. So you can see here, given the OGC API OpenAPI document, you can see the different transactional capabilities of a repository in pycsw. So in pycsw, in the configuration, you basically add a flag that says the repository is editable. And if it is, then this shows up and all the transactions are turned on, all the transaction capabilities are turned on. You need to put access control in front of pycsw so that it can, so that you don't have anybody making bad commits, if you will. And there's a very straightforward way of doing transactions using the Python OWS lib package. So very easy to work with metadata now given OGC API transactions in pycsw. We've also been working on a number of different specification updates. So as Angelos mentions, we've been following the specifications and working on the specification on the OGC API record specification itself and with the team. And part of that includes as the specifications move along, we're also moving along as fast as possible. We've also provided some documentation around our model, our underlying metadata repository model, as well as migration scripts because of some changes that are coming in future releases. And we're heavily involved in the OGC code sprints to help move forward the project. So like I said, the metadata code sprint in September, as well as the joint sprint between OGC, OSGeo, and the Apache Software Foundation in April, a couple months ago. Recent projects and deployments. So ESA's Earth Observation Exploitation Platform Carmen architecture is a collaborative virtual work environment, where you can access and work with EO data, algorithms, and tools. So part of that project involves a resource, what's called a resource catalog, where all the metadata about collections and scenes and so on is provided in this resource catalog, which is then made available for search. So pycsw is powering this tool, so it's a reference implementation of this EOEPCA architecture, and pycsw is used underneath. And they use both the CSW mode and the OGC API records mode, so it's really valuable to have the flexibility of the different APIs depending on the user requirements, as well as OpenSearch, right? Which is very prominent in a lot of EO data providers in Europe, for example. I also wanted to highlight this EJP soil. So from Paul Van Genuchten and Lewis's organization. So this is a joint program on agriculture, or co-fund on agriculture soil management. And what they've done is they've put together a catalog with participatory metadata management, which uses pycsw and a number of other tools. So it's really neat how they put this together. Basically, their source of truth are a number of metadata configurations that are managed on GitHub. And then every time the metadata is updated on GitHub, there's a there's some machinery which inserts that metadata into pycsw, and then it's made available thereafter. So really nice participatory and lightweight way to use pycsw in this kind of environment. So hats off to Lewis and Paul and company. The Norwegian Meteorological Institute has a number of pycsw installations for a number of their projects, and they use that as a search engine for discovering a number of their services. Yes, and we got one right here. Excellent. They have some ongoing work. I mean, they're very deeply involved in metadata and formats. So they're really we basically implemented the XSLT transformations for Metno, for that matter. So they continue to use the project heavily in a number of their activities. In my organization, Meteorological Services of Canada, we continue to use pycsw for international data exchange and discovery through the WMO, or the World Meteorological Organization Information System, or WIS. So we provide what's called a catalog for our data collection and production center using pycsw. I'll hand it over to Angelos.
All right, thank you. So regarding the roadmap of the project, as we already said, we are involved in the OGC API record SWIG. So we have been working with the standard group, and we are implementing standards on OGC API records and CQL support and everything that is involved there. What is coming, though, we are going to work on the federation part of the new standard, which will be probably an extension. We also plan to implement an Elasticsearch backend for pycsw. We already talked about PyGeoFilter, and of course we are also targeting to update our configuration text file to switch to YAML. About releases now, we are already doing alpha releases of pycsw 3. We are planning to tag pycsw 3 once we have passed the official site test for OGC API records, and that will also be a long-term stable release for CSW as well. Yeah. So about community. All right. Yeah, this is where you can find pycsw. We have a community page where you can find all our recent deployments. Please join us on the mailing list. We have a Gitter channel that you can find us and ask questions. Of course, source code and wiki and issues are all on GitHub, so you can go to the geopython/pycsw URL. And we also have a list of OSGeo service providers there if you need support for deploying your own catalog. So, thank you.